Okay, so suppose that these voltages in a three-phase circuit and 9 voltages are read out as follows. Okay, so 100 angle 0, 100 angle graph 120, 100 angle reflecting 120. Okay, so I forgot to draw the circuit. So the circuit looks like this. So if it is connected in Y. Okay, so it's connected in Y, and then the load is also connected to Y. So it looks like this. So it is 15 ohms. So this 10 ohms, this is J5. This is 6 ohms, and this is negative J8. So actually, it should be a resistor actually. So it should look like this. Okay. So it is measured using the 3 Wattmeter method. So let me draw that first. Like this. So this will be P1, this will be P2, and this will be P. Okay. So predict the wattmeter readings if the source is connected in Y. Okay. So the first thing to do is to solve for our P. So P1, P2, and P3. So they have the same formula for every P. So for P1, so that would be VAN multiplied by our IA, cosine of the phase angle. Okay, so difference of the phase angle, so that would be theta of our VAN minus theta of our IA. So that's the way how we solve it. So right after that, okay, so VAN is equal to what? So 100. So just consider the real part, okay, or the R. So IA is 6.67. Cosine of, what is theta of VAN? So that is 0. And what is theta of IA? So that's also 0. So cosine 0 is equal to what? That is simply equal to 1. Okay, so that is equal to 667 watts. We'll do the same for P2. So for P2, that will be VBN. So VBN is 100 still. What is IB? So that is 8.94. Cosine of 120 minus 93.44. And that would be equal to 800 watts. So check with your solution. So this might have a little discrepancy with the decimal place. So for our P3, we do the same. So that would be VCN and our IC. So that would be 100 multiplied by 10 cosine of negative 120 minus negative 66. Okay, negative and negative, that becomes positive. So that will be plus 66.87. And that would be equal to, that would be equal to 600 watts. So to obtain the total power PT, total power PT, so we're going to add everything up. So that would be 667 plus 800 plus 600. Okay, so P1 plus P2 plus P3, and that would be equal to 2067, which is the answer for letter B. So for letter A, these are the answers. for letter B, this is the answer. But alternatively, for letter B, we can solve for P1, P2, and P3 using this formula. So that would be IA quantity squared. Okay. And that is in its absolute value. And our resistance, only the real part, 15. So we'll multiply 15. So for P2, so IB, so 8.9, so that would be IB squared. So IB squared. So real part is 10. And for P3, that would be IC squared, which is 10 squared, multiplied by the real part in C, so which is 6. And you can obtain the same answer. As you can see, test for is 100 times 6, so that's 600. Okay. So 600, so 100 times 6, so 600. Okay, so as you can see, 667 squared times 15, and everything will be obtained with the same values. So this alternate solution, you can also use this formula. So let me write the formula here. So that would be I. So the node letter, absolute value squared, multiplied by the real part impedance, or simply R. So that's how we solve that. Okay, so do you have any problems or questions with the Wattmeter method? Okay, so this is a sample problem for that. So if you have any clarifications, you need some clarifications, you can hardly understand how the problem was solved, don't hesitate to send a private message to any of the medium you're most comfortable with, whichever you're most comfortable. So thank you for listening. So let's proceed with the 2 Wattmeter method in the next video. So see ya.